Hello guys, welcome to recitation number 20. I'm just going to share that right now for you guys to see the problems and we go through the solutions. So this is the first problem. And it says a cross-section of a wire is carefully examined while in a complete circuit. And the positive charges are seen to be moving in one direction to the right as shown. What kind of current is this and in what direction? So this is definitely a direct current. And depending on your notation or assumption, but I think your text uses the current to be the flow of protons, so the flow of positive charges. So positive charges are flowing to the right, so it's going to be a direct current to the right. Simple. Okay. The next question says, find the equivalent resistance. It says, find the equivalent resistance of the circuit shown. Use voltage as 9 volts and R for 10 ohms for each of them. So the voltage given is for a distraction. So for equivalent resistance, you don't need voltage. You just need to sum up all the resistance, except if you are giving voltage and current and you're not giving the resistance, then you can use Ohm's law to find equivalent resistance. But when you are giving the resistance of each resistor, you just sum. These three are in series, these two are in series, these two summed up in series, 10 plus 10, 20, that's what I have here. 10 plus 10 plus 10, 30, that's what I have here. Those combination are in parallel. So the ones that are on the same straight line are series. The ones that are separated in two branches, where if you cut one branch, current can still flow through the other branch. That's how you know they're in parallel. If I cut this off, current can still flow through this. If I cut this off, current can still flow through this. So this branch and this branch are in parallel. So I sum these two in series, I sum these three in series, and I sum both in parallel. And for parallel is inverse. So 1 over R equivalent is 1 over these two in series in parallel with 1 over this 3 in series. Okay, so it's 1 over 20 plus 1 over 30, 50 over 600. So R equivalent becomes the inverse of that, 600 over 50, and that's 12 ohms. Okay, let's go to the next problem. The next problem says, question 3. For the circuit shown below, find the voltage across and current through the resistor labeled R1. So use voltage as 9 volts. So this is going to be useful now. R is 100 ohms for everything except R1, which has 50 ohms. So first of all, find our R equivalent like we did before, 1 over 100 plus 100 plus 1 over 100 plus 100 plus 50. So we get that 1 over 200 plus 1 over 250 equals 450 over 50,000. So R equivalent is the inverse, 50,000 over 450, 111.1. So after getting that R equivalent, the next stage is to find the current in the whole circuit. So the current in the whole circuit from Ohm's law, V equivalent is I equivalent times R equivalent. The V equivalent is the 9 volts that's given in the problem. That's coming from the voltage source. So I equivalent is V equivalent over R equivalent, 9 over this. So now this current is the total current flowing through here. It's going to be shared between this branch and this branch, because these two branches, the one that has 2 R's and the one that has 3 R's, I call this branch A, I call this branch B. The current through branch A is different from the current through branch B. But the current through branch A is the same through R up and R down. And the current through branch B is the same for R, R1, and R. So in series, you have the same current, separate voltage drops. In parallel, you have the same voltage. So this is 9 volts. The voltage in this two branch, these two R's, this one branch is 9 volts. The voltage in this 3 R, R1 is also 9 volts. The same voltage, but different current. So how are we going to get the current? Just sum these two in series together, divide and get the voltage divided by that. You get the current through this branch. So we've gotten our I equivalent to be this. So V equivalent is the same as V through branch A, the same as V through branch B, 9 volts. Current through branch A is the V through branch A, which is the V equivalent divided by the resistance through branch A. So this should be A, not B. So resistance through branch A is 100 plus 100, 200, 9 over 200, 0.045 amperes. So that's my current through branch A. So what is the current through branch B? Is the same V equivalent, the same 9 volt divided by the total resistance through branch B, 100 plus 100 plus 50, 0.036 amperes. So this current is the second part of the problem. Actually, we're going to get the second part before the first part. This current here is the same current through R, R1, and R because they are in series. So this is the answer for the current through R1. Now, what is the voltage through R1? So the voltage through R, R1, and R is what is 9 volts. But the voltage through R1 alone, it will be the current through R1, which is the current through everything, multiplied by R1. So I1 is 0.036A. So V1, the voltage through R1 is I1 R1, 0.036 times 50 ohms, you get 1.8 volts. So this is one way. You can use your voltage divider and current divider formula to also do this, but I don't think you do that for the level of this class. So this is the way to just use basic Ohm's law to get this problem. So 1.8 volts is the voltage and 0.036 amperes is the current. Okay, thank you guys. And I'll see you guys. Say bye. Okay, I'll see you guys next week. Have a good one.